Hello students, welcome to the second part of this chapter, Redox reactions and rate of chemical reaction. Today we will discuss about oxidation and reduction. Elements combine to form compounds during chemical reaction. Examine the chemical reaction of magnesium with chlorine to form magnesium chloride. Mg plus Cl2 gives MgCl2. The electronic configuration of magnesium is 2A2. How many electrons does a magnesium atom donate? What will be the charge of magnesium ion formed here? See the equation. Mg gives Mg2 plus 2 electron. In a chemical reaction, magnesium loses 2 electrons to form magnesium ion. The electronic configuration of chlorine is 2H7. How many electrons are accepted by each chlorine atom? And what will be the charge acquired by each atom? You know chlorine gains 1 electron and acquire a negative charge to form chloride ion. The equation for this reaction can be written as Cl plus 1 electron gives Cl minus. The configuration of chlorine changes into 288 when it acquires a negative charge. The process of losing electron is called oxidation, and the process of gaining electron is called reduction. As magnesium loses electron and it gets oxidized, as chlorine gains electron and it gets reduced. The atom gets oxidized is magnesium, and the atom gets reduced is chlorine. Here chlorine is responsible for the oxidation of magnesium. So chlorine acts as an oxidizing agent. Similarly, magnesium is responsible for the reduction of chlorine. So magnesium is known as the reducing agent. Hence, in this equation, chlorine acts as an oxidizing agent and magnesium acts as a reducing agent. The substance which gets oxidized in a reaction is known as the reducing agent, and the substance which gets reduced in a reaction is called oxidizing agent. Consider another example, the chemical reaction of sodium with the fluorine to form sodium fluoride. Let's find out the oxidizing agent and reducing agent in this equation. Say 2Na plus F2 gives 2NaF. Na gives Na plus 1 electron. Sodium loses 1 electron and becomes sodium ion. That is, Na gives Na plus 1 electron. F plus 1 electron gives F minus. Fluorine gain 1 electron to form fluoride ion. Now the question is, which atom gets oxidized here? Which atom is reduced? Which is the oxidizing agent? And which is the reducing agent? From this equation, sodium loses 1 electron and becomes sodium ion. That means the atom donates electron gets oxidized. So sodium is responsible for the reduction of fluorine, hence sodium acts as a reducing agent. Similarly, fluorine accepts 1 electron to form fluoride ion. As fluorine is responsible for the oxidation of sodium, fluorine acts as an oxidizing agent. So sodium undergoes oxidation and acts as a reducing agent. Similarly, fluorine undergoes reduction and acts as an oxidizing agent. Look at another example. Mg plus F2 gives MgF2. Analyze this equation and find out the oxidized atom, reduced atom, oxidizing agent and reducing agent. In this equation, magnesium loses electron and it gets oxidized. Fluorine accepts electron and it gets reduced. Here the oxidized atom is magnesium and the reduced atom is fluorine. As magnesium is responsible for the reduction of fluorine, magnesium acts as a reducing agent and fluorine acts as an oxidizing agent. Now try to find out the following and complete the table 3.10 given in your textbook. Here is another worksheet. Analyze the following equations and complete the table 3.11 given in your textbook. Find out the equation of oxidation and reduction and identify the oxidizing agent and reducing agent. From these reactions, it is clear that during a chemical reaction, exchange of electron takes place and it results in the charge occurred for this electron, and this is called oxidation number. The oxidation number of an atom in a molecule is the formal charge assigned on the atom if all the bonds in the substance are considered to be ionic. In the next video, we will learn the process oxidation and reduction in terms of oxidation number.